What I want to look at in this video is the relationship between two planes in three-dimensional space, particularly one key aspect of them, and that's the angle between two planes. We want to know how they relate to each other in terms of these angles, such that we can start modelling scenarios using a variety of planes in relation to one another. Now, let's imagine we're going to look at two planes. So let's call them pi1 and pi2 here in this setup in this one. Now we can calculate the angle between any two planes by focusing on a set point B, which is on the line of intersection of both planes. So let's imagine this line here, P, that's where the two planes intersect. What we'll do is take some generic point upon that line, B, and what we've got here is we are able to draw two lines upon the vectors, so BA and BC, where they relate to two generic points, A and C, upon the vectors. What we can then say is that the angle ABC is the one that we require. Now it looks slightly more complex in three-dimensional space. Let's imagine what we'll do is take it and look at it from a 2D perspective at the sides so that we can look at the intersection of the two planes at B. So let's imagine what we'll do is we'll look at the two planes. So plane 1 is going up and down here in the red, plane 2 is going along in the black. Now what we want is this angle here, the angle between those two planes. Well, if we imagine that we've got the two planes and we take the normals between them, so there's my normal for the one plane and there's the normal for the other plane, if I was to calculate this angle here between the two planes, it would be the equivalent of this one, because all I've done is pinned this down here and done a 90-degree rotation round of both planes. We know that the normals are at a 90-degree, i.e. perpendicular relationship to those lines upon the plane. So if I was to look at the normals and calculate the angle between those, I would actually get the same angle between the two planes, because I've done that exact same rotation of 90 degrees looking at the two normals in both of those planes. So if we calculate the angle between those two vectors, those two normal vectors, using our vector product, what we'll get is the angle between the two planes. Now it's actually quite simple and straightforward in terms of the mathematics behind it and how we do it. So what I'm going to do is I'm going to show you an example, and you hopefully should see exactly what I mean fairly quickly. So let's imagine I've got two planes. One is given by x plus 2y plus z equals 5, and the second plane is given by x plus y equals 0. What I want to do is find the angle between the two planes with those equations. So let's imagine I've got my two planes here. So there's one and there's the other. So let's call this plane A and plane B. Let's imagine that's the equation of plane A and that's the equation of plane B. And I am wanting this angle between them. Let's imagine I'm looking at it from a side-on perspective, where this here represents the point of intersection along the line P, where that represents our line of intersection between the two planes. So essentially we've taken the two planes, there's one plane there, there's the other plane exactly as we've set up before, there's my line P, the line of intersection, and there is the point where they intersect. So I've got vectors on each plane here which are represented by this. Now if I was to take the normal of plane B, so let's call that NB, and the normal of plane A, so let's call that NA, and I was to calculate the angle between them, as I mentioned before, that would represent this angle here, because both planes essentially, by calculating the perpendicular to the planes, have made that same 90-degree movement and 90-degree rotation. So what I need to do is find both vectors, so find the normals vectors of both planes, and then use them. So if we look at the equations and inspect them both, there's A and there's B, I can look at them and say, right, so the normal vector of my plane A is given by 1, 2, 1, and the normal vector of my plane B, that is given by 1, 1, 0. So we can do that by inspection, by remembering the equation of a plane in Cartesian coordinates. Now remember, that is given by A dot P equals A dot Q. And in this one, remember, this P was just a generic point, so represented our x, y, z. The A was the normal, which was given by the coefficients of the x, y, z. So that's why I can initially just jump straight in and state the normal of both vectors NA and NB such that I've got them there. So what I now want to do is I want to use the vector product such that I'm able to calculate the angle between both of those planes, both of those normals, and that then gives me the angle between the two planes. So what I know then is from that is that cos theta is equal to A dot B over magnitude of A, magnitude of B. What that will give me is the angle between both of those planes, and I can get my solution from that. So what I'm going to do is the dot product of A and B, so let's do NA dot NB, scalar product of both my vectors. So I'm going to have 1 times 1, which is 1. I've then got 2 times 1, which is 2, then plus 1 times 0, which is 0. So my scalar product is just 3. My magnitude of A, so magnitude of NA, that's given by the square root of 1 squared plus 2 squared plus 1 squared. So that's 4 plus 1 plus 1. That there equals the square root of 6. The magnitude of the second normal, magnitude of NB, that's going to be given by the square root of 1 squared plus 1 squared. I can just ignore the 0. So that's then going to be given by root 2. So what I can say is fine. So cos theta is equal to 3 over root 6 times root 2. So from that I know that I can take cos minus 1 of it. So inverse cos of 3 over root 6 times root 2. That will give me the angle between the two planes, and when I do that I get 30 degrees. So the angle between my two normals is the equivalent of the angle between my two planes, which in this case is 30 degrees. It's a straightforward calculation to do. We just have to remember that relationship, cos theta equals A dot B over magnitude A, magnitude of B, and we just have to remember how to calculate the normals of the two planes such that we can then use them in that relationship. The angle between the two normals is the equivalent to the angle between the two planes. Fairly straightforward concept to get once we get our head around the steps involved and the properties that we're using in order to calculate our solution.